Okay, so we now learn how to solve the polynomial equations. Okay, and that would be one of the topics discussed in section 1.6 in class. So, more examples of how we can do polynomial equations. Example number 1 for today. We would like to solve 5x to the 4th equals 20x squared. And once again, the whole reason being I'm calling these equations here polynomial equations is just because now all the terms of the equation it all contains some sort of powers of x. So each term of the equation contains a power of x. And so that's why I'm calling it a polynomial equation. And so if you look back into the quadratic equations that we've learned how to solve earlier, quadratic equation itself is also a polynomial equation. But then it's a more specialized class, so that's why we have more techniques specifically designed for it. But here, for general polynomial equations, now when the powers goes even higher than 2, then we only can rely on one method. And that method is the factoring method, is the only method we can have. Now the guideline that I gave in class, the guideline here is step number 1, you always need to bring all terms to one side. And in my case, I prefer to leave all the terms on the left side, okay, and then leaving a 0 on the right-hand side. So, so now as step number 1 here, I need to subtract 20 because once again, like I said, we need to bring all terms to one side. And I prefer keeping it all on the left side, so I'm subtracting 20x squared. From both sides, my equation turns out to be 5x to the 4th minus 20x squared equals 0. Now I'm bringing my polynomial equation into the format, making it ready to solve. So now, at this point, the only access we have pretty much is the factoring method. Now, once again, if you're feeling if you're feeling shaky about your factoring skills, make sure you check out my other videos on how to factor. Okay, but now, what I see here, the only way how I can factor this is I have my GCF here. Throughout the two terms on my left-hand side, my only GCF is a 5x squared. So I'm going to factor out 5x squared, and then that means 5x squared times x squared minus 4, and all that equals 0. Okay? And so now, one thing I have to mention is you need to completely factor. Okay, so what I notice here is x squared minus 4, you can factor even a little further. Now the point here is that the 4 here is a perfect square, x squared itself is a perfect square. So here you have a difference of 2 squared, you've got x squared minus 2 squared. And so this quantity x squared minus 4, you can factor it further into x minus 2 quantity times x plus 2. And then the remaining factors, 5x squared multiply in front, that equals 0. So now you have completely factored your starting polynomial, 5x to the 4th minus 20x squared. This is how you turn that into a factor. So basically what factors are we having here? We have a factor 5, a non-zero factor. So 5 itself is a constant factor, or a non-zero factor. You have an x squared factor, which is x times x. You have an x minus 2, and you have an x plus 2. So, when you're solving these, at this point here, the only thing we can do, once again, we take each factor and we solve for 0. But then, when I said earlier about taking each factor and setting it equal to 0, we take each factor except the constant one. So I'm going to ignore the constant factor. 5 will never be equal to 1. Or in other words, you can think about you divide 5 away from both sides because it's a constant. So you have x squared times x minus 2 times x plus 2. That's one way how you can think about it. Or you can just simply think about, you ignore the constant factor. So now at this point here, to solve for x, I'm going to set x equals 0 because x is one of my factors. I have x squared right here, it's x times x. This thing here means x times x, just that. And so I have one solution. I have to set one factor, x equals 0. And I have another one, just identically the same, x equals 0, just the other one. Right? And then my next one here is x minus 2 equals 0. I produce for myself an equation to solve. And then the last factor, x plus 2 equals 0. And so now immediately these two x equals 0 already give you one solution. X equals 0 is one of them. With this next one, adding 2 to both sides, that gives you x equals 2. My second solution is to come. And my last one, subtracting 2 from both sides, that gives me x equals negative 2. So my equation ends up with 3 different solutions. Even though the x equals 0, you identically have 2 times. I've had it twice, but we count it just once. Example number 2, another example showing you how to do polynomial equations, how to solve polynomial equations. So we would like to solve again. Here I have a 4x cubed minus 12x squared equals 9x minus 27. Okay? And so, once again, step number 1 is always trying to bring all the terms to one side. Because here what I have is I see all my polynomial terms, all my power terms, they're all scattered throughout the 2 sides of the equation. So I need to bring my 9x to the other side and also bring my 27 to the other side. So I'm going to need to subtract 9x, and I also need to add 27. So I'm adding 27 to both sides. And that's going to leave me something like this. 4x squared minus 12x, 4x cubed, I'm sorry. So I have 4x cubed minus 12x squared minus 9x plus 27 equals 0. So now, and you can also see that I intentionally wrote my terms in a way that it has decreasing powers. So I got a cube power, and then the square power, and then the x power, and then there's no power for x. So as long as I have finished laying out all my terms for the polynomial, now I am ready to solve for this polynomial equation using the factoring. So once again, if you're feeling shaky with factoring, you need to go back and review your factoring skills. But here, the only way we can factor is using grouping methods. And so I can see that I can group 4x cubed minus 12x squared together, and then the other one minus 9x plus 27. I can group them together. And now what happens if you separate them into 2 groups? What's the sign in between these? What's the operations in between these? Isn't it just being blank? The answer is no. The sign is always a plus. Now what you can see is when I group them together with all the signs that came with it. So minus 9x plus 27, I group them all as is into one group, and all these. And then connecting between the 2 groups, it's a plus, always. And now the next thing I'm going to do for each group right here, I'm going to find the GCF, including signs. So my first group, among the 2 terms of the first group, my GCF would be the best GCF here would be a 4x squared. So I'm going to factor out 4x squared. Okay, and what I see remains is going to be x minus 3. Among my 2 terms in the second group, my GCF is going to be a minus 9. Okay, so I'm factoring out my minus 9 with minus 9, factoring out together with a plus, give me a minus 9. And then I have every sign in here. Since I factor out the GCF with negative signs for the GCF, every sign here remains, every sign in the remaining parentheses, switch signs. So, minus 3 equals 0. So now, if I'm looking at the 2 groups together, now I do see an underlining. I underline right here my GCF, one common factor for the 2 different groups. So that's my GCF right here. GCF. Okay, so I'm going to have to factor out the GCF, x minus 3. And then what remains in my parentheses is 4x squared minus 1 equals 0. And notice, if I factor this further, 4x squared, you can think of 4x squared. The underlining 4x squared right here is the same as 2x all squared, and 1 here is 1 squared. So you can once again use the difference of 2 squared. And so, like I said earlier, we always need to factor completely. So the first factor, x minus 3, nothing else we can do. So x minus 3. The next one, 4x squared minus 1, you can turn that into 2x minus 1 times 2x plus 1. And once again, the whole reason being, you are having the difference of two squares, two to the perfect square, and r equals 1. And so now when you come to this point, here is your three separate factors. X minus 3, 2x minus 1, 2x plus 1. Okay? So the final step here to solve the equation here is I'm going to have to take each factor, x minus 3, setting it equal to 0. Take the second one, 2x minus 1, set it equal to 0. 2x plus 1, setting it equal to 0. So for each sub-equation here, I'm producing for myself three sub-equations. For each of them, adding 3 to both. For this one here, for the first one, adding 3 to both sides, so x equals 3. That's my first, here comes my first solution. The next one, I'm adding 1 to both sides, that leaves me 2x equals 1, and I need to divide both sides by 2, and that leaves me x equals 1/2. And here's my second solution. And the last one, well, once again, I need to subtract 1 from both sides. I have 2x equals negative 1, dividing both sides by 2, that leaves me x equals negative 1/2. And that's how I can solve another polynomial equation.